our first training session on advanced business objects concepts. Today we will examine means of sourcing and identifying data from our colleagues' student information system. This training is designed for people with little to moderate experience with business objects. Today we will quickly go over the basic concepts in relational databases, then build an overview of the colleague CROA business objects system. 10 generic steps for creating business objects reports will be presented, and the 3 primary colleague research screens will be shown. Finally, we will run a practical example of how all this works together to help a query writer create a meaningful report. Older databases were structured like modern spreadsheets. These tables of data were arranged so that each row of data was a complete record of an instance of whatever was being recorded. Each column represented a field within that record. Each row had a unique key field that allowed for easy indexing of the data for rapid retrieval of information. Here we see one highlighted data field, most likely called owner, and one record, which tells us that an owner named Bill has a dog named Rover. This form of database worked well for small sets, but as data became larger and more complex, the system became less robust. In came the relational database model. In this model, common elements from the records are broken out into their own separate tables. Here you see one such table describing the breed, color, and birth date of a pet. Note that both these tables have a common key. Relational databases use these common keys to create links between the two tables. This, in effect, makes the two smaller tables act like a much larger table. Now we can combine the data in the two tables and even perform a calculation on one of the data fields to create new data, the age of the pet. In business objects, we have collections of related tables that we group into universes that share common focus, such as students or courses and faculty. Within these universes, the tables are linked in various ways. A series of joined tables is called a context. If you're pulling data only from tables within a given context, there shouldn't be any major issues in retrieving the information. If you try to pull data from some tables that are within a context and those that are not, you may encounter difficulties. You will also face challenges if you try to pull from more than one universe at a time. We will go over techniques that remedy these situations when we discuss merging in later training. Our student information system, colleague, is comprised of a tree structure of applications that contain the various tables that make up the system. At the base are the student, ST, human resources, HR, and the colleague financial, CF, applications. You may also have an application called colleague advancement, CA. Above these and connected to all is the core application. It contains information that spans the whole system, such as the person table, personal data on faculty, students, and staff. The utilities, UT, is the highest level of the tree, and it manages the processes within the system. The basic rule of thumb is that data can flow up the tree, but not down. So an enrollment by a student in the ST application can reach up to pull the student's name and age from core, but core cannot reach down to get the enrolled course taken by a given student. Most users interact with Colleague via browser-based interfaces that are driven by mnemonics, 3 to 4 letter acronyms that represent the title and function of the web page. Data can be viewed or entered in these web pages to update Colleague. Fields with a white background are for maintenance, that is, data entry, while fields with a colored background are for viewing data only. It is bad practice to pull reports directly from a production system, such as Colleague, so we have an operational data store, or ODS, that acts as a repository for some of the important data from Colleague. That way, users can generate reports without potentially crashing the main system. Our ODS is called CROA, Colleague Reports Operations and Analytics. Each night, an automatic process updates CROA for any changes made in the colleague database. The information in CROA, therefore, is not real time, but approximately 1 day behind reality. That is important to remember when trying to match your reports against colleague. If the data changed in the last 24 hours, your data won't match. But that doesn't necessarily mean your report was created incorrectly. You just need to wait 24 hours and test it again. Business Objects is fed data from CROA. Note that all of this is a one-way system. Nothing in CROA or Business Objects will change the data held in colleague. That can only be done via Mnemonic. Business Objects houses multiple universes, collections of related tables of data, each containing multiple contexts, linked tables, and data fields. Using the Field Help button on the Mnemonic will often provide the colleague table and field data for the information displayed on the screen. That table and field information can be used to identify the matching data field in Business Objects. We'll go over that shortly. A query is a means of pulling specific data out of CROA to use in a report. This can be done via a graphic user interface, GUI, or via a structured query language, SQL script. We will discuss query writing in depth in a later training session. The design interface allows the report writer to create new variables from the pulled data, filter out unneeded data, change a table into a crosstab, or even into a graphic. Most of the manipulation of the data for the eventual report happens here, not in the query. Conditional formatting rules, similar to those found in Excel, can be created and implemented in the design phase. Reporting is the final stage, whether simply sharing the web-based report with others, downloading it as a PDF, an Excel file, or a comma-separated value CSV data file. It is the end result that your users and your clients will be interacting with. These reports can be used to QA the data inputted into colleague for keying errors or for wider analysis and decision-making. Think of Business Objects folders as if they were tables in a database, and the listed items are fields in that table. You are pulling the data elements, the cells, to work with in your report. This is a generic 10-step process for creating Business Objects reports. While not perfect, this will guide you through most of the basic reports you will need to create. First, talk to the users to find out what fields and mnemonics they use. You may find that the data being entered is not what the field name would suggest it to be, or that it is the second or third value in a multi-valued field. The easiest way to determine this is by talking to the people who are actually doing the work. Once the screens are known, use the Field Help to try to identify the tables and fields from the colleague data dictionary. If you're lucky, all of your fields can be identified in this way. If not, you may have var fields. These are calculated fields or data views that will require more research to determine their source. We will cover those methods shortly. At this point, step 4, we're temporarily done with colleague and need to open up Business Objects. Our first choice is deciding which universe would most likely contain all of our data. In general, anything related to students, with the possible exception of financial aid details, can be found in the student universe. But other than that, you need to look around. Depending on the local setup and the particular fields you need, you may find course section data in the student, courses and faculty, or even the human resources universe. As you grow more familiar with the system and your reporting needs, you will develop a go-to universe. Trying to roughly match the CDD tables with the universe's folders is a good means of identifying the best universe to use. You can search for the fields by entering keywords in the search block and then reading the hover over tooltip by placing your mouse on the fields you are interested in. Build a simple query, no filters, and run a preview to determine if the data looks like what you're expecting to see. If so, run the query into a simple table and then select a few sample cases for testing. Pull them up in Colleague to see if the data coming out of Business Objects matches what is shown in the Colleague screen. Remember, recent changes may not be reflected in business objects. Now, in step 7, you can tighten up your query by adding filters or additional fields, such as descriptions, to help with your report. Run your query. At this point, you can create any unique variables for your report, merge any necessary fields, and generally get the data ready for reporting. In step 9, build a simple table. This is the easiest to QA and can be easily converted to other outputs such as graphs or crosstabs. Each row will show unique data, so you may find that certain frequently changing columns, like terms, can cause you to have multiple rows for a given value. You might find that you have 10 rows for a single student because that student attended 10 terms. You may need to delete columns, such as terms, to get single unique rows of the desired value. Such deletions may indicate either the need to split and then merge queries to create attribute values, or, if the client is willing, the creation of multiple simple reports rather than a single large one. In the final step, have your clients, the users, do a final validation of your report output against what they see in Colleague. Once validated, you can generalize your report and make it more useful by taking out query filter values that change over time, like term or year, and replacing the hard-coded value with user prompts. You can also make things easier on your clients by adding in user input filters to reduce the amount of data shown on the screen or in the downloaded reports. There are 4 main Colleague research screens, but we will only discuss the 3 most common ones here. We're leaving RDVF, Calculated Columns Inquiry, for the training session on formulas. You can detail down through these fields in the order shown or dive directly into any of them. RDEL provides you with the database element linkages, including the type and purpose of the field, as well as the table file name and the directory field name. RFEI is the file element inquiry, which provides interesting data on the table the field resides in. Keys are identified, related fields, and even computed column virtual field Unicode script is provided. Finally, RDEP, the database element presentation screen, provides details on how the field is shown on the screen, including the input prompt from the mnemonic. This latter provides a nice confirmation that you are selecting the correct field for your report. So let's do a real-life case showing how this works. Here's the request sent in by a client who I had worked with before and who therefore knew the type of information I needed to create the report. Select all active courses, including session cycle, CDD name crs.session.cycle, and term history, CDD unknown. Both elements are on the course offering info COFF screen. See attachment. The attachment was a screenshot with the 2 fields pointed out. So we know a few things just from looking at the request. We will need to examine courses, so we're likely to need either the courses and faculty or the student universe. Since nothing about students is mentioned, our best bet is to start out with the courses and faculty universe. We will need to filter the query to only provide active courses. We'll show how to do that in later training. We must open up COFF to confirm the CDD name for crs.session.cycle and to try to determine what data we're looking for as the, quote, term history, end quote. Reopening Colleague, we enter the mnemonic COFF for the course offering info and immediately see the session cycle field and the click box for term history. Detailing in on term history, we see on the XCTS course term history summary that it is a list, in no particular order, of when the course has been taught. The X in the start of the mnemonic indicates that it is a locally created screen and not a colleague-delivered page. That can make finding the field slightly more difficult. However, the heading in the first column does provide a clue, as there is a field in the universe called reporting term. Returning to the COFF screen, we click on the Field Help icon. On the browser tab that appears, we click on the View Full Help and try to find the fields we are interested in from the list provided. The list is roughly in the same order as the fields are on the screen, from the upper left to the lower right of the page. Clicking on Session Cycle, we see that our client was correct, crs.session.cycle. The first word indicates the table. CRS means the course table. That should be easy to find. Unfortunately, it seems that the reporting term field is not so obvious. It is showing up as a list.var1, generally meaning a computed field or a list field. This will require a bit more research. Now, I should note that in the vast majority of cases, in BusinessObjects, you won't need to go this deep to identify the data field and table, but it's good to know for the odd case when you will have to search for the data. If we try the RDEP screen, the Database Element Presentation, and search for the phrase reporting term, the ellipses before and after the phrase are wildcards, we see that there are 32 different fields with reporting term as part of their name. To narrow it down, we have to think about our data. We're examining courses and terms, not students or faculty, so views like AR, accounts receivable, and catalogs are not what we need. We keep looking until we find course sections, but it is a lower level of abstraction than course. Remember, we're looking up the directory tree, not down. Continuing to look, we find X courses. The leading X tells us this is a custom field that was created locally, but the level of abstraction, course, is correct. We take a deeper look at this field and find that it is not quite what we're looking for. The input prompt doesn't match, but it does give us a clue. The custom field contains a value for reporting term. We know from our experience that there is a field called that under the Courses folder in BusinessObjects. We know this is a local creation and a computed column, so we try drvf, computed columns inquiry, for this field, copying and pasting the complete field name. Nothing new here other than the fact it is a multi-valued field associated with term.history and the reporting.term. So we try our DEL, database element linkages, and find the same basic information, but we also now have a detail link on the table file that houses the field. Clicking that, we're taken to the RFEI screen, Field Element Inquiry. Now we see the keys to the table, the fields within it, and any actual computed virtual fields in that table. So we don't get a clear answer on this. Going back to the original request and talking to the client, we discover that he really doesn't want the X value in the box for reporting terms, but rather the list of reporting terms themselves. Given that and what we found so far, we do discover a possibility. We can try using the reporting terms field under the courses folder in BusinessObjects, as it seems to be the basic information being used to make this computed field. Taking a brief look at our other variable, crs.session.cycle, it behaves nicely in our DEL, letting us know that it is in the courses table. We can read through the courses table by drilling down into the RFEI. We can then move to BusinessObjects and start building our query. The first decision we have to make is what universe to use. Given that we are focused on data related to courses and not enrollments or other student data, the courses and faculty universe seems to be a sensible start. Once in the query window, we take advantage of the search function to find our known field. We type session, and the course sessions cycle S70 field appears in our list. The S70 is a unique code to Southwestern College that indicates this field was added locally and not part of the standard delivered CROA database. We hover over the field, and sure enough, in the description we see that the field is coming from crs.session.cycle, exactly what we hoped. We select that field by double-clicking. Then we search for our second field by entering the search phrase reporting term, and we get two options: the field in the Terms folder or the field in the Course Sections folder. Hovering over the Terms option, we see it is coming from the Terms table, while hovering over the other shows it is from Sections under Course Sections. Since we know that if a section of a course is offered in a term, that course is considered offered, it seems logical that we would use this more discrete data for our report. We select the Course Sections version. In running a data preview, we see that we get what we expected, but we need course identifying data as well, so we add course title and name and then run the query. We have multiple listings for each class, one for each reporting term. We can bounce back to the COFF and colleague to validate that the correct terms are coming through. On the COFF screen itself, we see the reporting terms are shown in descending order. But when we click on the detail icon for reporting terms on the XCTS screen, they're in ascending order. A quick check, and it seems that we're capturing all of the terms that we need. But our client doesn't really want a huge list like this. The client wanted the data for cycles and that for reporting terms. It makes sense to remove the reporting terms column from this report and use it later in another report. We'll cover how to build that report in our training on crosstabs. We do so. Now we have a list with only one row per course as we wanted it. We can check the session cycle data against the COFF screen, and again, we have the correct data. Now all that remains is to make the report more attractive and useful. We should set up the print parameters, perhaps add in some related columns, build a variable or two to convert the session code to a cycle description, and put in some input controls to let the user narrow down the report to only what he or she needs to see. How to do all those things are topics of future trainings. That's it for now. We hope you found this useful, and we look forward to seeing you in future training sessions, where we will work on other advanced aspects of query writing and report generation. Have a wonderful day.